Awesome. Perfect. Thank you for having me. What a wonderful community you have. It's an honor to present here the second time now in less than a year. I think last time it was November or December of last year. Today, we're going to talk about web performance, and we're also going to have some fun with JavaScript. This is a really long topic, by the way. It's a 2-day training that I end up doing, and I'm going to do a 1-hour presentation. And I'm also going to show a lot more code this time because Abdul let me know that you also have a lot of backend developers. So I wanted to show some code that works both for JavaScript as well as backend developers. And one thing to keep in mind is, good developers know how things work and great developers know why things work. And that's more important. And today I'm also going to show you how you can make some of this happen on your own. And then we're going to understand web performance, identify any kind of bottlenecks we have, try to make our code faster, and repeat it in kind of a loop. So let's get to code. I'm not sure if you've ever used OpenAI, but it's an amazing tool. So here I'm telling it to create a JavaScript array of 200 animals. And this is important because a lot of times I don't have time to test something and I just want fake data. So I just click that and it's giving me a bunch of animals. And as you can see, I've got different animals starting with the name, alphabet A, and then I've got B and a lot of others. That's going to keep happening. This is nice, right? Because instead of going to Google and trying to get everything, I can now just get all this data here, and then we'll start working with the data. While this is doing this, why don't we also get a JavaScript array of all countries in the world, and it's going to write the code for us. Now, I know what developers are thinking. Oh my gosh, this is AI doing everything. What's going to happen to my job? Don't worry. It doesn't write the most performing code yet. Might change in a few years. So we're going to have to figure something else out. But for now, our jobs are pretty safe. And I'll show you some examples of where AI will not be able to do every single thing. You still need a human. So you notice that I had to press submit 3 different times because it stops and then it's got to go to the next level. So these are some of the animals. Let's take the animals and we're going to move to our code, which actually, let's just go to WebStorm. Oops, picked the wrong one right here. So we're going to take all these animals and see what we got. All right, so let's just change that to let. Now, how are we going to do this? Now, I wanted to share this code. So if you are practicing at home and you want to do performance yourself, you can easily do something like this. Now, what am I doing? I've got a function that runs itself. The reason I wanted to do that is just to make sure that we are not, basically encroaching the other function. So it's not the best code, but it basically lets you see one screen and you're going to start. This is where your start happens, means you get the timestamp for that particular second or millisecond, and then you run your function, and then you have the end, and then you talk about execution time, right? So this is filter.js. I've got animals. What are we looking for? Animals that start with W. Actually, we should go back and also look at the fact that we had an element with W, actually. So let's see if I can bring that. Do we have anything with W? Yep, we do. So not bad. All right, let's go forward. Actually, let me just get these 2 close enough. Now, if I were to go to index.html, I've got my source, which is filter.js, which was this particular file. First thing it's going to do is use animal.filter function, which is basically on any array you have, there's a filter function. And all it's saying is if it starts with W, great. The second way of doing the same exact thing is this particular code base where you would have a for loop. And then you're going to go one by one on every single string. And you're going to say if it starts with W, great. That's perfect. Now let's go run this. And I've got Chrome. And in this Chrome, I've got this right here. So let's go to our developer tools. Let's go in here and run this. So once you do that, you'll notice the execution time on the first one was 0 milliseconds, and the second one is 0.1 milliseconds. That's pretty incredible. There's a huge difference here just with the way you write the code. All right, so let's look at how can we test it more. Now, one of the other easy ways of testing something is always get more data, right? So a hack that you can use is, and let's do this on the fly. I wouldn't do this in real life because you would work with real data and everything, but just that fact that we're testing everything. Let's run this, and then Do this again. Oh, wow, look at that. That one was 0.2 and that was 1.9. Now, one thing you got to understand is that this is not always going to be accurate. So run it a few different times. Wow, look at that. That's 80% time. So this is 0.4 millisecond and that's 0.5 milliseconds. So that's 20% faster. In this case, actually about 25% faster if you go from 0.5, or if you go from 0.4, basically it's 25% extra, right? So the way it's either 20% faster or 25, depends on how you calculate it. Not bad. That's a pretty significant performance increase. I'm running it again a few times. This is again 0.29, 0.39. It's pretty close. And after some time, the browser also tries to do its magic. But for the most part, that one is actually smaller, right? Now, can we make it bigger? Let's just go make it bigger. Let's just make it a really big array and see what happens. And we can also change our function, right? So let's say, give me something that starts with A. I could do the same thing here and run this. All right, so let's see what we got. Wow, 0.39 and 0.6. You see, that's pretty incredible. So in this case, it's taking 67% of the time, so about 33% faster. 0.59, and the previous one is 0.39, right? So again, 0.79, 0.6. So always, you notice, for the most part, Animals, the filter event is so much faster than a simple for loop that you have here. Can you make the for loop better? Yes, you can. I mean, you can use a divide and conquer algorithm or something similar, but understand that in this case, I don't even like this code, right? You're actually working with arrays. You've got these square brackets here. I mean, it's a lot going on, whereas this is a really simple function where I get to decide what my function is going to be, and for every value, just pass starts with. It's incredible. Beautiful, really fast, and so much more in terms of performance later. All right, so I did promise you we were going to have some JavaScript fun, right? So let's have some JavaScript fun, because most of the times what happens is people start working on this language and they go, wait, I didn't even know this, and what does that mean? Let's try some of this, right? So if you probably know this, actually, let me just do node so we can run JavaScript, and watch this. 0.1 plus 0.2, you would have expected that to be 3, but in real life, in JavaScript, that's actually true. That means it's not equal to 0.3. And that's because you probably saw that there's a 4 behind that, right? So this is a seriously interesting use case, and you got to be aware of it. Now look at another one. A lot of times people go, well, what's the answer of that? Well, actually, it's 99. Why is that? Well, the reason it's 99 is because JavaScript's smart enough to know, well, one of them is a string, or in this case, a character, and the other one is an integer. And if you concatenate those, because you have plus, it's going to work like that. However, if you do this, it's smart enough to know, oh, wait, that's just a character. Let's just convert it to integer. So the answer is 18. All right, so I'm going to print these two answers so you can see that one's 99 and that one is 18. Why do I bring this up? Because when you are working in a dynamic language, even though you're doing Node.js or you're doing JavaScript in the back end, I mean, it's still the same exact story, and it's going to do things that it does. So let's check this out. You may have thought of type of null. Oh, wait a minute, happens to be an object. Wow. So what do you do if you have null in your code? All right. Maybe you write code like null is instance of object. Oh, wait a minute, that's a false. Right? So these are things you have to be extremely careful of, because a lot of times, you may be writing high-performing code, but it may not actually be what you think it is. And then you're like, wait a minute, not a number means not a number, but type of not a number is number. So this is why this is JavaScript fun, right? And then you go, wait, how do you check for not a number? Well, let's just do 3 equals, because as you know, 2 equals only checks for the value, but 3 equals actually checks for also the type, right? So we have not a number. Wait a minute, 3 equals not a number is false. Interesting, right? So what about a new array? If you have a new array, what's your answer? That's your answer, right? Now, what if I do this? Oh my gosh, new array equals to be false. And that's actually true, right? So this is where you probably want to do something like a 3 triples. And well, that's now going to be a false. Makes sense. So anyways, this is just JavaScript fun. Let's move on to one of our examples. So now, what do we do if we were to have a little more complex example of merging, right? So let's go to our AI, and I'm gonna tell the AI, create 2 JavaScript arrays and merge them. Now, it did a very good job. Actually, it's a beautiful job. Let's do that, and then we're gonna say, merge them without concat function. I know what the developers are thinking. If AI can write all this code, what am I doing, right? So have a look. The first one, it took array 1, which is this, and then it took array 2, and then it concatenated it using a dot concat function. Perfect, no problem whatsoever. Second one, I told the AI to write this function without concat. So it had 2 different arrays, and it runs through the list and creates a new array, merged array, and then pushes the first array right here. And this is array 1, and then it pushes array 2. So merged array is going to have both the values. Pretty incredible. So let's go to our code base. And this is where the humans shine over AI, because AI sometimes doesn't even know what's the best performing method. Now let's show you that. So what I'm going to do now is I'm going to have my HTML basically go to merge.js. And what's merge doing? It needs countries and it needs animals. So let's go and get our animals. All right, so we got the animals and we push all our animals here. Perfect. And then we're going to add all our countries. And oh, wow, it did not finish doing the countries yet. Wow, pretty incredible. So we got all the countries. So let's get the countries, and then you notice how the AI keeps using a var. Well, that's probably not a very good thing. So let's change that to a let. So we got the countries, we got the animals. So what are we doing here? The first one is simply countries.concatenate animals, and always have a semicolon. That's a good idea. And then we're going to look at the execution time. Then secondly, what we're going to do is use, so that was the first one, by the way, and this was exactly what we used. And the second one is going to be this merging of this array, both of them. So we have 2 for loops, and then they keep pushing those animals, and then they push those countries, and then we have a performance on that. And then the third one is where I'm using a different function called countries.push.apply, and that will end up taking countries and animals, and now create the new array, which is still countries, and it will have all of them. So it's 3 different ways of doing the same exact thing. All right, so let's go and see what it gives us. I'm going to do Command R. All right, so we got execution time 0.29, 0.29, and 0.2. So you should see this one is 33% faster, because this is 0.3, 0.3, and 0.2. Now that's for the amount of values you have. Wait a minute, for some reason we only get 412 values here. So maybe we didn't do something right. Countries and animals, .push, countries and animals, .push. And even with that many less values, for some reason, it wasn't working very well. Interesting. So what really happened? I'm not going to debug the code here, but you get the idea. You can try it at home. However, let's go and change the data and make it bigger. Okay. So I've got a bunch of countries here. I'm going to do the same with animals. I could have easily told the AI to print a 2000 or whatever, but it'll take some time. So I decided not to do that. And now let's run this. Already ran. Wow, look at that. 1 millisecond. Now, the only reason this is faster is because it has less values. We can fix that in a second, but that one's 1.19 milliseconds, and that's interesting. Run it again, about 1.2. That one's actually faster. And you keep looking at this. Now that's actually faster. I mean, it's actually slower. So once you run a bunch of these, you're going to know that overall, you still will get the most value here in that particular one, especially if you have larger arrays. But do not just try to do this with this value. Try to do it with multiple different values. With bigger arrays, you're better off going this route. And in a normal situation, you would do something like this. Now, you realize that this isn't the best code either, because they have a lot of commonalities here. In this case, if you wanted unique values, you were better off using a set than an array. But I just wanted to show you different ways you can merge arrays, and then you can see these values, right? So real quick, in this case, the reason it takes a little bit longer is because of this. Now, what happened here? Okay, so that's countries. That's what happened here. So that was actually supposed to be animals. Let's fix this real quick. I didn't even pay attention. Copy paste errors. That's another problem with code like that. We'll always get paste errors. So now you see the time increased, and we got the same value. So I actually fixed it. So some of these examples give you an idea of how much different time lag you have and how things are slower because of that. And the larger you get, this particular thing will work fine for you. But let's say you have an array of 50 states in the United States. In that case, you know that it's a lot smaller and you can work with smaller data. And these are just some examples of how you can screenshot it. Really, all you have to do is start the time on your Windows window, in this case, performance, and end it, and then check your execution time. And this is a function with immediately invoked function expression, and it runs like that. Another thing that a lot of people want to know is how to use tools, right? So one of the things we always have is a console tab, which is great. We use it all the time. We have debugging, right? But network tab is always extremely important to know how things are working out. So let's go to CNN.com. And you see, wow, it's taken seconds. Oh my gosh. Wow, the load time is more than 7 seconds, right? So there's something not very good about this thing. There's so many different ways we can fix this. And you now can check the time here and look at, oh, what happened here? Oh, wait, so we had 118 milliseconds for particularly that thing, but that particular load is taking 5.4 seconds. And this is now, you know, all right, where the code is, what are you getting, what's your problem, all of that. And then can you cache some of this? Is this one time? Things like that. You have a lot of different ways you can start looking at it. But first thing to know is load time, and that's right here. And in a lot of cases, the things we do, we have a really small load time, nothing as big, because the load time of 9.78 is almost unacceptable, right? So let's go to bbc.com and see what happens in this case. And you go, okay, well, it's still loading. It's going forever. I mean, but load time, it says about 2.82 milliseconds to a second, sorry. It's not that bad. And then it probably has some calls that it keeps doing as it's loading, which is a little smarter, right? So you have this auction, which is 950 milliseconds, something we can investigate, but gives you some idea of how to use these tools. And then you can also do performance. So one of the things about performance is hit the button and then go to the website. Why is that? Because you want to see the entire load and let it profile every single thing. And I think in about 6-7 seconds it loads. So you kind of know how long to go, and then say stop. And once you stop, there's a lot of beautiful things it shows you. And there's a lot of data that's going to start showing up. It's going to start showing you the profiling. It's going to show you the network. It's going to show you the frames, for example. In this case, you can even look at what kind of frames you had. You know, how much time was taken in scripting, how much time was taken in rendering, and all of that. And, you know, another way to look at this is if you actually say frame, you have show frames per second. And that's your meter up there, and it can tell you in real time what kind of frames there are. So if you were to play a video or whatever, you start noticing it's an HTML game, you'll notice that you're dropping frames like right and left because of the way things work. But I'm not going to play a video right now, just to give you some context. And another good one happens to be Lighthouse, right? This is where you should start nowadays because it gives you a lot of things. So let's bring up YouTube. All right, so we got YouTube. And as you can see, the frames are on that side. And I'm going to start analyzing page load. So what does it do? It changes into some kind of mobile interface. It reloads the website. As you know, it went to m.youtube.com, which is basically the mobile page. And now look at that. Oh, no. So YouTube gets only a 54 on performance, and the only thing it's getting green is 93. That's pretty interesting, right? So check this out. It's going to tell you things like, wow, first contentful paint, it took 4.3 seconds. Time to interactive was 9.5 seconds. So you couldn't even interact with it until that time. Interesting. Unused JavaScript. Now this is, depends, right? Sometimes you don't use the scripts on page load, and sometimes you really never use them again. Well, in that case, you got to remove it. But if you did not use it on page load, but you used it on an interaction, well, then you're gonna have to check what that really means. And then you have preload large contentful paint image, and it even tells you what that image is. And if you have it for, let's say, a phone device, you don't have to have the big size for the phone device. You can always make it a much smaller image per device you have. And that doesn't mean for every single phone device. It means for a phone-ish device, have a different size altogether. For more like, like an iPad or a tablet, have a different size. And for a desktop, have a different size of the picture. And that's important because sometimes you may be using CSS, but the picture load is still the same high resolution picture. That doesn't even make any difference whatsoever in a mobile scenario. And then it talks about unused CSS and even tells you exactly where your CSS is. And you can look into it and it says, oh, transfer size was 50 kibs, which basically means you could save that much time by removing that. And then, of course, it also talks about PWA and other things, and it does all those audits for you. Oh, by the way, it's not the best website for accessibility. And, there's a lot of detail here. And then it talks about best practices like serve images with low resolution. Well, the example that I was giving you earlier, it's already telling you that that's one of the fixes. And then, of course, it says, hey, if you want to know all the issues, go to the issues panel in Chrome DevTools, and then missing source maps for large party, JavaScript. That's another thing that's missing. Now, it does get a lot of good numbers on 93, which is the highest score it has on SEO. So that's pretty incredible. But performance 54, it's a very low performance score, right? And look at that. I mean, this is actually on a very low end, 54 out of 100, not very good. There's a lot of things we can make better here. Let's do CNN. So we go to CNN.com, and now the lighthouse should be, let's run another one. So you go right here. Actually, you could definitely do this again. I'm gonna have to remove that and create a new report and analyze the load page. Actually, let's just do it. Real quick, it will not be the same as YouTube. I think it'll be way faster because this website doesn't have a lot of videos and a lot of those scripts going on. It's a much simpler website, and you hope it is faster. Actually taking a lot of time. That's not the load. That's Lighthouse doing its analysis, so that sometimes does take time. And it also gives you some ideas here, by the way, so that's pretty incredible. Oh no, performance is 9. Wow, that is not acceptable at all. Interesting. So same story, blocking time, big one, not something you want to ever do. So we've got about 15 or 17 minutes. What I would like to do is talk through some of this theory, and I'm going to skip through slides that are not important. And by the way, some of this was covered last year. So make sure that you go through that long 1-hour video. It's available on YouTube, and I spoke at your user group and at your conference, and that was great. But in short, you should be faster by 250 milliseconds from your customer or your competitor website, and that means you won the game. And one of the studies to read about is FT.com intentionally delayed their speed. And they said, what happens if we slow down the page or the blog post or anything like that by 5 seconds, 3 seconds, 2 seconds, or 1 second? And the results were pretty astonishing. Think about it. Even if the web page was 1% slower, 5% user dropped out. And if it was 3 seconds slower, 7.2% users dropped out in just 7 days, right? And then you can see the numbers for 28 days. It was 4.6%, 5%, and 7.9%. So you're losing anywhere between 5 to 8% users very quickly just by reducing 1 to 3 seconds in your articles. And we just saw some websites that were taking so long to render, and that is, interestingly, a way to lose your customers. Watch that. This number is pretty big for me. That was tablets. You notice with 1 second on tablet, about 20% users. That's 19% right there that left you. And look at the numbers on desktop. 6.3, they're okay. Desktop users probably have more patience, and tablet users, like 14% are leaving in 28 days, and in 7 days, about 18%. That's pretty incredible. And mobile too, the numbers are still higher. Not as high as tablet, but higher than desktop. So let's talk about performance, right? How does it work? If you have a website that doesn't load at all, loads a little bit, barely anything, and then loads the entire page, and you have another website that loads a little bit more, loads a little bit more, and loads here, which one you're going to like? Most people would like the first website because it loaded in 3 seconds. You do the same on mobile, same story, people would be the same way. However, if you have a website that partially loads in the second and then loads fully, that's better than a website that barely loads and then loads fully. So you still will go with the above approach. Interestingly, if you actually have a website like that, that may even load a little longer, but just because it had progressive rendering, most people like the above than the one below, because performance isn't as important as perception. The perception is, oh, that website already started loading faster than this one because it had nothing for the first 2 seconds. And sometimes you lose people in just 2 seconds going, it's taking forever. 2 seconds, a lot of time for users in today's world. So one of the books to read about HTTP 1.1 was 14 Rules of Web Performance. The book was High Performance Websites by Steve Souders, and he says a lot of great things. Over a period of time, people realized that those were great patterns and practices, but then some of it changed down the line. And what does that mean? So for example, right, he says put scripts at the bottom. That's very, very true. But let's say you go to Amazon.com or some other website and you want to search for a 24-inch monitor. The problem with putting scripts at the bottom is they will only run when the entire page has been loaded. What is the most critical functionality on Amazon.com or a lot of e-commerce websites? It is the ability to search. So I think the better approach to do this would be where you have a script that is on the head, not the body, and it takes care of the search functionality while everything else loads and all the other scripts are at the bottom. So that's a little bit performance hack, but it makes your website so much faster and users so much happier. Because imagine your website loads like one of the websites we saw earlier, loading in 9 seconds. Would you really want to wait for 9 seconds before you type your 24-inch monitor or 27-inch monitor? Probably not. You probably go to a competitor's website. So since we noticed that users will leave your website pretty quickly, that's something to keep in mind. All right, so one thing to understand is how browsers work. And the way browsers work is they have a protocol. So for example, we're going from San Francisco to New York, and let's assume one round trip time happens to be 42 milliseconds, means you're going to send a synchronization to the server, and that server is going to send an acknowledgement back, and it takes 42 milliseconds. Once we've established that we're going to talk to each other, next thing that happens is there's a request to the server. And let's assume the processing time happens to be 50 milliseconds, so it's already taken us 92 milliseconds, but then it's going to get back to us in 113 milliseconds because it takes 21 milliseconds from the server to get to us. Now that's assuming if you have 10x segments, which basically means 14 kilobytes. And this is how HTTP 1.1 works on TCP. And if you notice, by the time you get all these bytes, which is only 116 kilobytes, you've already spent 240 milliseconds the first time you talk to it. Now, HTTP 2 solves those problems and makes your life so much easier because you can have a lot more data come in and go, and you can establish a pretty amazing channel, which is bidirectional. This is not how HTTP 1.1 used to work. So if unfortunately you're on HTTP 1.1, the best practice is to move out of that and move to HTTP 2. But if you are on HTTP 1.1, then a lot of these actually work for you because you got to minify the JavaScript, right? You're going to bundle everything together. You're going to reduce the size. You're going to reduce the downloads and all that. And why is that? So let's talk about why that happens the way it happens in a second. And we'll forget the tips for a second. Before that, one thing to keep in mind is when you are on a browser, which is a mobile browser, understand that battery is extremely important. So you may be getting high performance, but if you're losing the battery, that's not a very good thing. Number two, if you have a lot of network calls, that's radio. So your screen and radio are two very energy intensive components. And even though you may have the best website, you got to be careful how you're using those resources. Otherwise, your performance is not going to be very good. And then people are going to start quitting your websites. So how do you save battery? One thing you can do is prefetch data. Instead of making 10 calls, make one call, prefetch a lot of data, and then minimize your periodic data request. Not always the best case, but in some cases it works really well. So it's going to be on a case-to-case basis. We look at a customer's use cases, and we accordingly give them referrals and recommendations on how to make things work. Now, HTTP 2, as I mentioned, has a lot of good benefits, like you have server push. You can also create weights and dependencies on stream prioritization, and you also have header compression, and you can now have both SYN and sync ACK packets, and they're consumed by the receiving end during initial handshake, and that basically is going to save you at least one full round-trip time compared to standard TCP. And of course, HTTP 3 is here now, so things are so much better. So what's the most important thing for a web developer? Well, it is the time taken to get to the first render of the page. So how does it work? Let's say the network, you've got HTML and you've got CSS. There's only two things on the page, right? HTML is the markup that shows and puts all the elements together, and CSS gives them a certain look and feel. And then JavaScript is blocking. Why is JavaScript blocking? JavaScript's blocking because it can change the DOM and the CSS object model, which is also called CSS OM. So for example, you are on a browser, the browser starts downloading the website, as in the HTML file, and what it starts doing is showing you how these things are downloaded. And as it goes line by line, it starts showing and rendering things on the right-hand side, which basically is your rendered object model. And I want to show you this real quick because the DOM could have something like the div has a hello world, and then it's got a paragraph which is hidden, right? So the render tree is really the most important thing. Once it looks at your HTML as well as CSS, the render tree now is what gets rendered. So a lot of people focus on the DOM. DOM is not what gets rendered, basically. It's the render tree that actually gets rendered. DOM tells the browser how to render the render tree. So in this case, the DOM will have paragraph, which is hidden, but you look at the render tree. Render tree doesn't have anything. It only has the div hello world, and since P, which is paragraph, is hidden, it doesn't matter to the render tree. And what's on the render tree gets rendered. So you see on the right-hand side, it says hello world. Perfect. Now, tips, right? One thing you can do is server-side rendering, which can be fast. You can also do progressive rendering. You can also get critical. This is important. Not all CSS, but critical CSS can be in line because you don't want it to download a new file, right? So if there is some kind of styling you want to give to the first division or div on your page that had the search bar, something like Google or Amazon has, well, in that case, you just give it that critical CSS in line, and that's going to save you a lot of time because CSS, when downloads happen, it blocks the rendering. So this is where the problems start happening. The more JavaScript you use, understand, the more you are blocking, and that's sometimes good and sometimes it's not very good. So take an example in this case. Look at the green. The green one, analytics.js, is async. And what does that mean? The async will not actually block anything. However, the red one, it does not have async, so it's not downloading asynchronously, so it's going to block everything. The benefit of the green one is it executes when it's ready, whereas the red one will block, then parse, and then execute. So that's why it's slower, and it's going to block you. And blocking is probably not the best thing for you, unless it's critical JavaScript. So how did older browsers used to work? Well, they would download a script, then parse, and then execute, and then they'll download another script, parse, and execute, and then they'll go get the CSS and the images. Well, not very efficient. Later, they realized, oh, wait a minute, we could do this in parallel. So let's do, a bunch of these in parallel. In the beginning, it was 2 per domain or subdomain, and then it became like 8, and then it got more than that. But in short, parallel download still means you still have to wait for parsing and execution, and then you got to download other things. So that's why you got to be careful how you have these scripts. Gmail Mobile, they use a beautiful technique. Whenever they compose any, email on the browser, which is a mobile browser, they realize a lot of people just check their images and reply. They don't necessarily hit compose on a mobile browser. So what they did was they decided to uncomment that code. Why is that? Well, because they decided to uncomment that code because they didn't want to pay for the parsing and execution. The first time, though, they use that code, they uncomment it, and then they eval it. So in this case, it's your own code, and it's getting eval, and it's something that can easily work. Not a problem, as long as you have the right APIs and controls in the backend, you should be good to go. But otherwise, eval is usually a bad idea, right? So that's something, if you know what you're doing, great. If not, I mean, could be a security headache. So what are the JavaScript tips? JavaScript can block CSS object model as well as DOM. So use async and avoid document.write because it's blocking. And the last thing is very important. So if you're on HTTP 1, right, defer all but critical scripts towards the end of the body tag. And even in HTTP 2, this is not a bad strategy. It's just that you have a lot of other ways to do similar things. But for the most part, critical scripts can be at the top as long as they're pretty minimal and they're not bulky, and then the rest stays at the bottom. So what is layout and paint? Well, these are the two most expensive operations because eventually you have the render tree, but then you got to lay it out and then you got to paint. You know how a lot of people talk about frames per second. I showed you earlier how to see the frames per second on both the performance tab as well as the frame meter. And really what a frame is 60 frames, which most people like to be 60 frames. That's a pretty good fast game, or even HTML5 game or whatever. At the end of the day, one frame is 1,000 milliseconds. That's about 1 second. If you divide that by 60, you got about 16.67 milliseconds. And usually the browser is going to take 4 or 5 milliseconds. So if you have anything that exceeds 11 milliseconds for the most part, and that's just like a average number, the frames start getting dropped. Now, what is a frame? In a frame, you have to do 4 things. You have code, garbage collection, layout, and paint. The problem with this scenario is that everyone thinks, well, we're going to have the code and then garbage collection, then layout and paint, so it's going to work out fine. Well, that's theory. In real life, anytime you do resizing or adding nodes or remove nodes or change any CSS styles or some kind of, anything similar on the JavaScript side of the story, you'll end up in a situation like this. So look at the right-hand side. You have code, then you have layout, then you have code, you have layout, and it keeps going on forever, and eventually you're going to drop frames. So what do we do here? Well, we ended up using the wrong way of forcing paint. And what is that? We took the style and we keep changing it while we are in a for loop. And every time we do that, it does not it doesn't happen the way it is happening on the left-hand side, which is once you have code and garbage collection and then layout and paint. What it does, it triggers code, layout, and it re-triggers layout every single time in the for loop. And they want to definitely fix. An easy fix would be to use some local variable, and that should be a good idea. And then you go from layout to paint. What happens is you have to apply the visual styles. You got to create the bitmap. You got to pixelate the screen. So in that case, paint is going to be triggered. So basically, you're forcing it to trigger paint, which is a very expensive operation. So what do? Make sure you update the minimum area needed, right? So if that's going to happen in some kind of dynamic div, well, make sure that's a really small area, and that's the part that changes, and that div should not be a huge, part of the body element. It should not be like, if you do it on the body element, everything is going to update, right? So find that particular div that you really need to update, and just make sure the updates are happening particularly at that particular location for that particular area on the browser. So layout, right? Look at this. This code will trigger reflow 3 times. That basically means you're going to trigger paint, and that's going to slow you down. So how do we do it faster? Well, right there. What you can do is push all of that in one style and change the CSS text. What are you doing wrong in this case? Well, every single line, you keep changing the layout, which basically triggers paint, and that's your reflow operation, and that's 3 times. Here, that's 1 time. In this particular scenario, you got the element dot offset left, and every time you access that property, well, you're going to be in trouble. If you have a for loop 500 times, you're going to be in trouble. In this case, it's going to be called twice, but let's just say you had a for loop, it'll be called 500 times. Not a very good performance technique. What do you do now? Well, just use cached offset left, which is a local variable, and then you got to worry about it nothing at all, because you're not accessing that variable more than once. So it's way more efficient. So paint, as I said earlier, most expensive part of the pixel pipeline. Changing any property is going to get you there. Trigger paint without layout, all that kind of stuff. It's a bad idea. And then reflow is when DROM tree is manipulated. Repaint is like redraw. So what do? Repaint is better than reflow. I'll give you some examples. Here's a good example. Take a fragment, document fragment. Do everything in the document fragment, and then last line, append the fragment in the body. What's going to happen? You will trigger it one time. The entire for loop is not going to trigger anything except repaint, not a reflow. Again, another example, you could do the same thing with cloning the node, and then last line, take the cloned one and take the original and now make the cloned the original, and you got to make it work in one line of code. All of that for loop is not going to affect anything because we're cloning it. We're not doing anything on the DOM. And the final one, you can always say style is display none. And once you're done with all the changes, you can do last line, which is change the display to block. So in these three scenarios, what do? We took everything in memory, made it happen, and we now published it. Now we have the reflow, and it's way faster, and you will never have performance issues whatsoever. I think I'm 1 minute above my time, so I think that's pretty much what I wanted to cover, and definitely watch the presentation from last year, and if you want to reach out to me, add me on LinkedIn, and if you have any questions, let me know. Thank you so much for having me.
Yeah, thank you very much, Mr. Chandler, for this beautiful keynote, and you definitely guided us with some new features to improve our web. So let's take 1 or 2 minutes for if anyone have any questions in the chat. So we already have a question. Is there any way to optimize images instead of compression?
So what's the question again?
Is there any way to optimize images instead of compression? Maybe.
Yeah, so gzip and all, there's a lot of different ways, right? You don't want to always compress an image because sometimes you don't really get the value out of it. So one of the things that always works is, image per device. And what does that really mean? That simply means that, whatever device is going to render that, create the best resolution for that particular image, right? So if you take like YouTube, let's just go to YouTube real quick. And let's say you bring up any YouTube video. One thing you'll notice is if you have it, like images and videos, right? Same thing applies here. So one of the things they'll do is basically in this video, for example, you notice right here, you go to the settings and it will be smart enough somewhere to, I don't know where it is, but usually, well, I think that's the ad. But in short, if you are on your cell phone, it'll be 420p. And if you are on a browser, it's usually 1080p. And it also looks into, other things like what kind of network connections and all you're using. So same with pictures, right? This is a big enough picture or a video, whatever you want to call it for now. But if you are on your iPhone, you don't need to have such high resolution pictures. So one thing you may want to do is create different images for the same particular image and now put it per device. That way, you will never download a higher resolution picture than your device needs. And that's a much better way of doing it. Number two, you can use CDNs, right? So you can use different CDNs. And that's always a good idea. Why is that? Because, there's Cloudflare CDN, right? Akamai, there's Fastly and all. Because a lot of those images, you want it to be as close as possible to your customer, and they will load the images so much better. So one thing is have the right size per device, and then use CDNs, and that's going to be so much better. A lot of times what happens is people start using gzip, and they don't realize that images as well as PDFs sometimes become bigger after doing gzip or whatever. So you got to play with that, but don't get too excited about it. That compression actually doesn't work very well, but you got to have the image size correct and resolution for the device you're targeting, right? Because you can't have, let's say, a 50 megabit pixel picture on an iPhone. It doesn't really help you as much, right? I don't know if that helps answer the question, Abe. If you have any other question, let me know.
We got also another question of our images. Is it better to use the image tag instead of background image property in CSS?
That totally depends on exactly what you're trying to do. But yeah, I'm not a big fan of background image property either myself. So yeah, you're probably better off that way.
Okay. Isn't differ better than async? That's another question, I think.
What's better than async?
Differ? Not,
Oh yeah,
Defer.
you could do defer and async. Yeah, so they both have different use cases. But yeah, I mean nowadays you have defer. Previously you didn't. So yeah, that's a good point actually. I should update my slide. So thank you for that.
Okay. Seems no other question. We thank you very much again, our GDE and MVP, Mr. Chandar Dal. We hope to see you in the future events and maybe sometime in Lebanon in person.
I would love to be there in person sometime. So really excited about that. Thank you so much for having me. Have a great day and have a great event.
Okay.